Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on September 30th, 2025, about a week ago. This paper shows that training autorators to predict full preference distributions yield sizable gains, including 18 to 51% lower mean squared error, 4 to 45% lower calibration error, and 7 to 81% better positional bias consistency. The paper is titled Judging with Confidence, Calibrating Autorators to Preference Distributions. And as we will see, the implications for evaluation and alignment are quite significant. In short, calibrated probabilistic judgments reduce bias while preserving accuracy on objective tasks. Alright, Figure 1 contrasts two judging styles and shows why calibrated probabilities matter. The left workflow illustrates a probabilistic autorator that predicts a full preference distribution, which means it outputs a probability like 0.6 for response B rather than a single verdict. The method is tuned through supervised fine-tuning or reinforcement learning, so the verbalized number matches population votes. On the right, the bar charts indicate lower alignment in calibration errors and higher agreement for the fine-tuned judges, especially the reinforcement learning variant. So Figure 1 showed why calibrated probabilities matter. Table 1 summarizes the main results, and the takeaway is that distribution matching improves alignment, performance, and calibration over prompting or logic tweaks. On Gemma 29b, reinforcement learning with a Brier reward achieves a mean squared error of 0.0764, which signals the closest fit to the target distribution. That same model reaches agreement of 0.871. It also posts the best Brier score at 0.095. On QN 2.57b, the reinforcement learning Brier variant leads with agreement of 0.858, so the gains hold across architectures. Alright, Table 1 just highlighted performance gains. Figure 2 shows how different methods handle positional bias on QN 2.57b. Symmetry deviation means how far the two swapped probabilities add up from 1, so 0 indicates perfect swap symmetry. Baseline boxes skew right toward response B, which signals a systematic ordering preference. The bottom row, RL Brier, clusters tightly around 0 and achieves consistency near 0.901, indicating strong debiasing. So the bias analysis just showed strong debiasing. Table 4 confirms that calibration does not cost accuracy on objective tasks. JudgeBench is a suite of fact-check comparisons, which means each pair has a single correct verdict. Our Gemma 29b with RL Brier leads reasoning at 55%. Its overall accuracy lands at 47%. Quinn 2.57b follows closely at 45%. Among fine-tuned baselines, Skywork Critic 8b posts the highest overall mark at 53%. Okay, two takeaways stand out. Calibrated probabilistic judges that predict full preference distributions, reduce positional bias, and improve calibration without sacrificing accuracy on objective tasks. And reinforcement learning with a Brier reward is annotation efficient while generalizing across models. The broader implication is more trustworthy, fairer evaluations that expose uncertainty for safer alignment. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.